Hello everyone and welcome to Module 2. In this module we will be covering Chapter 2, and the subject of the chapter is motion in a straight line or one-dimensional motion. The following chapter, Chapter 3, we will be covering motion in 2 dimensions or motion in the plane. Let's go over this topic briefly before we start doing problems. As you may recall, there is a formula that you have studied back in maybe high school or middle school where it says that speed is equal to distance divided by time, right? We can say that speed, let's call it v, and distance, we'll call it x or delta x over a time interval, let's say delta t, okay? The meaning of this equation is this. Let's say, for example, I tell you that last weekend I drove from Las Vegas to LA, for example, and the distance between them, let's say 300 miles, and it took me a delta t, a time of, let's say, 5 hours to get there. Okay, so what is my average speed, v, or v bar? Bar means average here. So it's just distance over time, just like this one. So I go 300 miles divided by 5, and that'll be equal to 60 miles per hour. Okay, so my average speed was going 60 miles an hour. Now, that doesn't mean that I started from Las Vegas, and for the next 5 hours I was driving non-stop at exactly 60 miles an hour. That's just not possible, right? Your speed is constantly going up and down. Say sometimes you're going 70 miles an hour or 55 miles an hour or maybe 45 miles an hour and so on. But overall, your overall speed is around 60. So that's why we call it the average speed. That's one thing. So that's the meaning of the word average or V bar. Another thing is, let's say I'm interested in what is called the instantaneous speed. The instantaneous speed, kind of a big mouthful word, instantaneous. What that means is the following. Let's say I started driving, let's say 12 noon, okay? And of course it took me 5 hours, so that means I arrived there by 5 p.m. Is that okay? If you ask me, what was your speed at, let's say, 1:13 and 35 seconds? Okay, so at 1 o'clock, 13 minutes and 35 seconds. You see what I'm saying? This is a very precise time, and I want to know what my speed was at that precise time. Well, what we call that the instantaneous velocity. Okay, so that means the instantaneous velocity is your velocity or your speed at a very, very specific time. Unlike the average speed, where it is your overall speed, an average of 60 miles an hour, even though going up and down, the speed goes up and down, but that's the overall. But instantaneous means at a specific time, what was your speed? That's what we call the instantaneous speed. Okay, so that's basically the difference between them. Okay, so the topics I want to talk about in this video are 2 topics. One, it is what is called the Equations of Kinematics. And the other one is free fall. These are the 2 topics. Free fall kinematics, that is. Okay, so let me start with kinematics. Now, when we say the word kinematics here, it's basically the study of motion without asking what caused the motion. See, what causes the motion is a force, right? But without worrying about that, basically we are looking at the motion of an object and asking the question, for example, what would be the position of the object after, say, 5 seconds? Or let's say the object is speeding up. So what's the speed of the object after, 12 seconds and so on, okay? Or what is the, how long it will take the object to arrive at a specific point and so on, okay? These are kinematics, okay? So basically we are trying to predict the evolution of a moving object in terms of what is the position of that object at that future time, or the future velocity of that object, given that it is speeding up or slowing down and so on, okay? And these are governed by three famous equations that I urge you to memorize them, at least be familiar with them, and they are V equals V naught plus AT, V squared equals V naught squared plus 2AX, and X equals V naught T plus, 1/2 AT squared, okay? These are called the equations of kinematics. I'm sure if you've taken a course in physics in high school, you're probably familiar with them. And I'm going to call them equation 1, 2, and 3, and in that particular order. Those three equations are equivalent, okay? So it doesn't matter which one do you use to solve problems. But each of them has its own flavor. For example, if you look at the first one, it has the naught here means initial velocity. And if there is no naught underneath it, it means final velocity, okay? So here it gives you the initial velocity, the acceleration, and the time, and it asks you to find, say, the final velocity. Here it gives you the initial velocity, the acceleration, and the displacement, or the distance traveled, and it also asks you to find the final velocity. Here you are given the time, acceleration, and initial velocity, and you are asked to find the displacement, okay? So each of them has its own variables, but you are welcome to use any of them depending because they will give you basically the same answer. I'm going to show you some examples right now. For example, let's look at one from the book, example number 2.5, and I'm going to do some homework problems for you. So you go back to the book, and example 2.5, I'm looking at the hard copy here. It's on page 40, so I'm just going to go here, type in and there it is right here. Let me magnify it a little bit. It basically says the following. In this first example of constant accelerated motion, we will simply consider a car that is initially traveling along a straight stretch of highway at 15 meters per second. Okay, so we want to write down what's given to us. Let me move this away a little bit here and write down what's given to us. So it says we have a car, and it is V naught equals 15 meters per second. At t equals 0, the car begins to accelerate at the rate of 2 meters per second squared. So at t equals 0, the acceleration of the car is 2 meters per second squared in order to pass a truck, okay? Now he's asking, what is the velocity of the car after 5 seconds have elapsed, okay? So we want to know the speed of the car, the final velocity, after, what is it? After a time of 5 seconds. You got that? Okay, so how do we do this problem? So always, when you read a problem, always write down what's given to you and what the problem is asking. So what's given to us is the initial velocity, the acceleration, and the time. He's asking for the final velocity. Now I come to those kinematic equations and I'll look which one is best suitable for our problem. If you look at equation number 2 here, see, this one contains velocities, both final and initial, and acceleration, and it has displacement. Well, there is no displacement mentioned in the problem. And of course, this equation does not mention the time, even though the time is given to us. So this equation will not be useful to us. The second one, similarly for equation number 3, we have the time, we have the initial velocity, and this equation will allow us to find the displacement, but he's asking for the velocity. So this is, again, this is not the proper equation for this problem. The best one actually is the first one. As you can see, time is given to us, the acceleration is given, the initial is given. All I need to do is to plug all of that, all those numbers in here, and then to get the final velocity. So the equation number one is the most useful for us. So you got to go V equals V naught plus AT. All I need to do is just plug it in. So I have 15 plus A, which is 2, times T is 5. And then I calculate that, so that'll be 15 plus 10. And the answer is 25 meters per second. Okay, there we go. That's the final velocity of the car. If it starts speeding up at the rate of 2 meters per second to pass the truck. Got it? Okay. One more problem, and that is number 2.6. Let me go back to the book. Should be the next page. It's right here. So it is kind of a follow-up of the previous problem. He said, let's revisit example 5, the one we just talked about, and calculate how far the car travels during the 5 seconds of acceleration. Okay? So basically, I think I mentioned that. So given that we have the initial velocity is 15, acceleration is equal to 2, and the time interval is 5 seconds, what is the displacement x? And as I said in the previous problem, probably the second equation, we can actually use the, the third equation, but we can actually use the second. I'm going to show you, if we use either 2 or 3, it will give us the same answer. Let me show you. So let's start with the easier one, which is number 3, equation number 3 right here. So it is x equal v naught t plus 1/2 at squared. That will give it the displacement. So let me try it. So we have x equals v naught t plus 1/2 at squared. Plug everything in. I got 15 times 5 plus 1/2 times 2 for the acceleration. And the time is 5 squared, right? So that will give me 15 times 5. That'll be, 75, plus the 2 half cancel out, plus 25, and the final answer is 100 meters. So the car has traveled 100 meters. Now I can use the second equation, equation number 2, right there, this one, and hopefully I will get the same answer. Let me write it down and show you. So here I have v squared equals v naught squared plus 2ax. Of course, I want to do the algebra first. So I'm going to take solve for x. So that's going to be v squared minus v naught squared over 2a. That will give me x, correct? And now v squared, I found it from the previous problem right there. This is v squared right here, or v rather. So it's 25 squared minus v naught, which is 15 squared, is given to us, divided by 2 times the acceleration, which is 2. Hopefully we will get 100. We should get 100, right? So that will be equal to 25 squared is 625, 15 squared is 225, divided by 4, and that will give me 625 minus 225, that will be 400, divided by 4, and of course that's equal to 100. Whoops, I'm beyond the screen. That will give us 100 meters. And there we go, we got the same answer. So it doesn't really matter which equation which kinematic equation you use, you should get the same answer. Okay. All right, one more example. Example 2.7, I think. Yes, we'll do 2.7 as well. Let me go over it. The next page also. There it is. Let me read it very quickly. It says, now we will apply equation 2011. He's basically talking about the equations of kinematics. He writes them a little bit different. I like my version. You know what I mean? So anyway, so he said we will apply kinematic to the problem. Okay, so he said a sports car is sitting at rest in a freeway entrance ramp. The driver sees a break in the traffic and floors the car's acceleration so that the car accelerates at a constant of 4.9 meters squared. So this is the acceleration, 4.9. We need to write it down. And as it moves in a straight line onto the highway or the freeway, what distance does the car travel in reaching a freeway speed of 30 meters per second? Okay? So how do we do this problem? Well, let's write down what's given to us. Always write down what's given to you. So here I have so the acceleration is 4.9 meter per second squared. The time at t equals 0, the velocity of the car was 0. How do I know that? That's what he said. Yeah, let's go back to the problem. He said a sports car is sitting at rest in the freeway entrance ramp, which means at t equals 0, in the beginning, the car was at rest. So that's the initial velocity. And then he pushed on the brake and he accelerates at a rate of 4.9 and moves in a straight line. So now he's saying how much distance, he said, what distance does the car travel when it reaches a speed of 30? So that's the final speed is 30. So here we have v is equal to 30 meters per second. And now he's asking for x. Again, we go back to the kinematic equation. Let me write it down again for you here. V equals v naught plus at. V squared equals v naught squared plus 2ax. X equals v naught t plus 1/2 at squared. Okay? And we want to pick which one is best for our situation. Now look at what's given to us. And he wants x. So I can use either this equation or this equation. You see what I'm saying? He did not give us time, however. In other words, he didn't give us how long it took the car to go from 0 to 30. So I'm going to ignore the time factor, which is right here, this equation. So I'm going to be basically using the second equation. Right, it's this one here. Because it doesn't contain time. You see what I'm saying? So I'm going to use that. So that's going to be, I'll write it down here. V squared equals v naught plus 2ax. Always, guys, do the algebra before you plug in the numbers. So he's asking for x. So I need to solve for x. Again, don't plug in the numbers now, too early. Solve for x first. So x is equal to, if you do the algebra, v squared minus v, oops, this is squared here, sorry. V naught squared over 2a. And that will be equal to 30 squared minus 0 divided by 2a, so that 2 times a is equal to 4.9, and that'll be 900 divided by 9.8. And when I calculate that, so the distance traveled is 92 meters. There we go. Now, if I ask the question, I don't know if it's in the example or not, how long did it take the driver to go from 0 to 30? Okay? I don't know if it's asking, but let's assume that we want to know that. Well, I can either use the third equation right here, or I can use the first equation, solve for t, for both in both cases. You see what I'm saying? So I can use the first one because it's easier. So let me ask this question. How long it took to go from v naught equals 0 to v equals 30 meters per second. How long did it take him? Well, we can use the first equation. V equals v naught plus at. Again, do the algebra, solve for t. So that's going to give me t is equal to v minus v naught over a. So that will be 30 minus 0 over 4.9. I'm going to use my calculator. And that will be 30 divided by 4.9, answer 6.12 or 6.1 seconds. So it took the driver 6.1 second to reach that speed. Okay. Okay, great. One more example. I'm going through them very quickly. Example 2.8 from the book. Looks a little bit harder than the ones we have done so far, so let's go over it. Page 45. Here it is at the top right here. He says, in this example, we will, for the first time, look at constant acceleration motion of two objects moving simultaneously. Okay. Clearly, we will need to describe position and velocity of each separately and then use the resulting equation to answer blah, blah, blah. Okay, so let's start from here. He says, suppose that a motorist is traveling at a constant velocity of 50 meters per second. Now, when we read the word constant here, guys, constant means what? No acceleration. A equals 0. You see what I'm saying? Okay, so we have a motorist. I don't know if he specified it, the motorcycle guy. Did he say motorist or motorcyclist? Motorist. Traveling at 50 meters per second and passes a school crossing corner, which is right here, where the speed limit is 10 meters per second. Okay. A police officer, oh, okay, the motorcyclist is the police officer. I got it. Okay, so the motorist is the van here, or SUV, whatever you call it. So that's the motorist right here, and that's the police officer. Okay. And the motorist is going at a speed of 50 meters per second. And so he passes this school zone, and the school zone says 10 meters per second. Got it so far? Okay. A police officer on a motorcycle stopped at the corner, then start off in pursuit with a constant acceleration of 3. So now the police officer is starting from velocity 0, correct? And now he is accelerating at the rate of 3 meters per second squared. Okay? Question: how much time elapses before the officer catches up with the car? Well, you can pause the video and think about it. But basically what it is, see, the motorist, this SUV guy, he's traveling at constant speed. He's not accelerating at all, or decelerating. He's not slowing down. He's not speeding up. However, the one that is accelerating is the police officer. So let's assume the police officer started here. So that's velocity 0. And then he starts accelerating from 0, or maybe here. It's starting from 0 until he reaches the motorist, right? So in order for him to reach the motorist, he has to go from 0 to 15. Make sense? Okay. So let's work it out. He said how much time elapses before the officer catches up with it. Okay. So here we have, so let's write down what's given to us. So here we have two situations. Basically you have, let's call them police, and let's say the other person, we'll just call it a car. Okay, how about that? So what's given to us? Well, the car has a constant velocity of 50 meters per second, and of course the acceleration is 0. He said it's constant velocity. For the policeman, however, the initial velocity of the police is 0, and the acceleration of the police is, what is it, 3, I think? Yeah, 3 meters per second squared. And the initial is 0. The first part of the problem, the first part of the problem, he's asking for how long it will take the policeman to catch up with the motorist, right? Let me read it again very quickly. He said, how much time elapses before the officer catches up with the car? Okay, so here's how it works. So the policeman starts. So let's assume the moment the policeman starts moving, the clock starts ticking. I want to know how long it will take him until he get there. Now, see, by the time the officer catches up with the car, both should have the same position, correct? Because once he catches up with the car right here, they would have the same position. In other words, by the time the police officer catches up with the car, both must have traveled the same distance. This is important. I mean, you have to find kind of a link between the car and the police, and that's the link is right there. Is that by the time the police officer catches up with the car, both must have traveled the same distance. In other words, I can do it this way. I can say that the distance traveled by the police officer, x sub p, must equal to the distance traveled by the car. Of course, on the back, on the side here, I have my kinematic equation, v equals v naught plus at, v squared equals v naught squared plus 2ax, and x equals v naught t plus 1/2 at squared. These are the equations that I have that I need to use to solve, okay? All right, so how do we do it? Well, okay, let's start with the police officer. I need to find the distance traveled, because they both have the same distance by the time they catch up with each other. Okay, so the distance traveled, I'm just going to go directly to this one here, because since he's asking for the time, so I'm just going to go to the third equation. So I'm going to write it as v naught t plus 1/2 at squared. What about the car? Well, the car, remember, it's going at constant speed. The acceleration is 0. So all I need to do is to use the formula that has 0 acceleration, which is the one we started when we started the lecture with. Remember, it's velocity equals delta x over delta t, or velocity equal distance over time, or if you want, just x equals vt. You see what I'm saying? Whoops. Again, I reached the end of my window is very short here. Anyway, there it is. I'll just put it here. X equals vt. Simplest equation. I'm sure you've seen it before. So I'm going to use that. So x sub c here is basically v for the motorist, the car, times t. And those two times should be equal to each other. Because, again, like I said, if you have the clock start ticking, well, it's going to be ticking for once the policeman started moving, that clock is ticking for both of them. So by the time the policeman catches up with the car, both must have traveled the same distance, and they will agree on the same time, how long it took. So the times here are the same. But before I do that, you know that v naught is equal to 0 for the police, right? Remember, it's right here, started with. So I have here 1/2 a t squared equals vct. The t here cancel out with this one, and I have 1/2 a t equals v sub c. What is v sub c? Well, it's 15. We got it right here. This is v sub c right there. I can actually put a c right here because it's constant speed, the velocity of the car. So now I have 1/2 times the acceleration is 3, correct? Here it is, right there, times t equals 15, and then that's 3/2. So therefore the time is 15 times 2 over 3, and that will give me 10 seconds. There we go. So it took the officer 10 seconds to catch up with the car. You got it? Now, that would be basically the first part, part A. Part B, he says, what is the officer's speed at that point? So the officer is speeding up. By the time he catches up with the car, what is his speed? Well, we just use one of the kinematic equations. I would go with probably the first one. It's just too simple. I have the initial velocity, 0. Final, I have it. Or, I'm sorry, he's asking what it is. And I have the acceleration and the time. time I found it from part A, that is. So let's do it. So we have V equals V naught plus AT. That's 0 plus 3 times 10. And that will give me 30 meters per second. So by the time the police officer catches up with the car, he's going 30 meters per second. And part C, what's the total distance the officer had traveled at that time? Basically, he wants x sub p. We didn't calculate it. Remember, we used it in this relationship to solve for t, for time, but we didn't really calculate it. So I can either use the right-hand side of the equation or the left-hand side of the equation. It's basically going to give me the distance. So let me use let's start with the right-hand side, which is x sub c, which is equal to x sub b, is equal to 15t, correct? Just like I did here, 15t. What did I get 15t from? It's VCT. VC is what? 15 right there. So basically the distance traveled is equal to 15 times 30, see what I'm saying? And that would be equal to, what is that, 150? I'm sorry, the time is 10, I beg your pardon. And that will be 150 meters. Another way of doing it is to use the left-hand side of the equation, which is right this one, or this one right here. See what I'm saying? So I can say x sub p, which is equal to x sub c, and that's 1/2 at squared. That'll be 1/2 times 3 times t is 10 squared. So that'll be 3/2 times 100. And what is that equal to? That'll be 300 over 2, and that will be 150 meters. Either will give you the same answer. You got it, guys? Okay, good. Okay, that's basically what I wanted to talk about regarding kinematic equations. Now I want to move on to the next topic, and that is free fall kinematics. Okay, so what is free fall? When we say free fall, it means when you have an object, let's say you're holding an object in your hand, say a pencil, and then you drop it off your hand. You're not throwing it, you just drop it off your hand, and what's going to happen to it? It's going to drop down to the floor, right? So let's say we have a height. There is the height right here. And I have an object, say a pencil. I'm just going to draw a little circle, symbolizing it. And I'm holding it in my hand. So that means the initial velocity of this object, or the pencil, is 0, right? And that is the height right here. Let's call it y, because it's vertical. And so I let go of the pencil, and what's going to happen? The pencil is going to drop down and then hit the floor. There we go, something like that, okay? Here's a question. How long is the object in flight? That'd be one question to ask. Another question, what is the velocity of the object just before it hit the ground? You know what I mean? Like right at the infinitesimal distance, right before it hit the floor, right, say, here, you have to use my mouse to show you, right before here, what would be the velocity of that object? So those are two questions that we can ask. Again, we can use the kinematic equation, the one we are familiar with. Let me talk a little bit about them and show you how we can, change them slightly to fit our problem. So we have here v equals v naught plus at, v squared equals v naught squared plus 2ax, and then x equals v naught t plus 1/2 at squared. Now, when we talk about free fall, we are constantly talking about vertical motion, or motion in up and down, you know, vertical up and down. So what I want to do, I want to make the x becomes y, okay? It's kind of a better notation because y is the vertical axis, you see what I'm saying? And then also, while the object is falling, it has a constant acceleration, and this acceleration we refer to it as the acceleration due to gravity. So A here, we call it G, small letter G, and this G has a constant value for Earth on the surface of the Earth or the sea level, and it's equal to 9.8 meter per second squared. We always use this this number for acceleration due to gravity. One more thing, since the object is falling down, which is in this direction, go back to this diagram right here, and it's going down, so the direction of motion is in this direction, downward this way, and the G is downward. So I'm gonna replace those pluses that you see here with minuses because it's going down, okay? So in this case, I'm gonna rewrite my kinematic equations in this fashion. V equals V naught minus GT, see that? V squared equals V naught squared minus 2GY, okay? And then Y equals V naught T minus 1/2 GT squared. Now we have the same kinematic equation, except that it is customized or tailored for free fall, and we refer to them as free fall kinematics, FF kinematics. Okay. So now I want to answer the question that we just posed, and that is, what is the time of flight of the object? How long it took the object to fall to the ground? And what is the velocity of the object just before it hit the ground? Okay, so let me start with the second one, which is what is the velocity of the object just before it hit the ground? Let's assume that we have the height. Let's assume that the height is equal to, let's say, 10 meters. Okay. One more thing, there is one more details to it. Because I am holding the object here, okay, and if I can imagine that I have X and Y axis right there. Here is the Y, and there is the X. You see what I'm saying? Let me take this out just for a minute. So here is the X axis right here, and there is the Y axis right here. Notice that this is the negative side of the Y axis, correct? So if it's on the negative side, that means the height here becomes a negative. You see that? This is just sign notation. You get that? Make sure you understand that, because I have my X and Y right at the pencil while I'm holding it. So this side of the coordinate, the vertical coordinate, is the negative side, and so therefore anything I measure, any distance rather than I measure in the vertical direction here, is equal to is a negative number. Excuse me. Okay. So let's start with since I don't know the time, I'm going to use the second kinematic equation, this one. Okay. I'm going to write it down again. So I have V squared equals V naught squared minus 2GY. And then I'm going to put in my numbers. Remember, I'm trying to find the velocity, okay, just before it hit the ground. So the initial velocity here is 0, because I'm holding it between my fingers initially at t equals 0, minus 2 times 9.8 times what? The Y. What is the Y? Negative 10. So in this case, I will have the minus here, and the minus here will become positive. So I have plus, and then 2.8 times, 2 times 9.8 times 10, and that will give me 196, I think. Let me just use my calculator. 2 times 9.8 times 10, it's 196. So I have here 196. And of course, this is velocity squared, so therefore velocity is equal to the square root of that, 196. And what is the square root of 196? I believe it's 14. Again, I'm using my calculator, and the answer is what? 14. Now, if you remember from your math classes, what is the square root of, say, 9? What is that equal to? Your math teacher would tell you plus or minus 3, correct? And the square root of 16 is plus or minus 4, and so on. Well, which one do we pick? It's the same thing, so that will be like something like plus or minus 14. Well, which one do we pick? 14 meters per second. Which one do we pick? Well, since we're asking for velocity, which means direction, look at the diagram again. By the time the object comes here, right there, the velocity direction is downward this way, correct? This is the velocity right here. And as you can see, it's downward, so it's going to be negative. So when we take the square root here, we actually pick the negative sign. So the answer is negative 14 meters per second. Do you see the sign convention? And there we go. That's the answer. So negative here means downward. Okay. All right. Let's take something a little bit more complicated. I have an example here from my notes. It's not in your book, but it's kind of a neat example. Imagine I am on top of, say, a building or some height. There it is. And this height is 50 meters. And I throw an object straight up like this. Here is the object. I'm holding it between my fingers, for example, or in my hand. And I throw it up like that. Up, 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 and then it comes down. I'm trying to make it as neat as possible, and then it comes down here. Okay? So it goes up with some initial velocity. You see that? There is some initial velocity. Let's assume that this initial velocity is equal to 20 meters per second. Okay? And there are 1, 2, 3, 4, 5 questions. Here they are. I'm going to write them down for you. First, what is the time to reach maximum height? In other words, how long it will take this object to reach the maximum height, which is right here, the summit right there. Okay? B, what is the maximum height? In other words, what is the maximum height? Let's say we're measuring it from the ground. So what is that maximum height here? And part C, what is the time to return to the level of the thrower? In other words, the object is here. How long it will take it to go through this parabolic path until it is right here, okay, to the level of the throw, which is somewhere right here, and of course going down this way. How long it will take it to get here? This is the time to return. And then part D, what's the velocity at this stage, the velocity of the object there? At level of the thrower, that is. And then part E, the last one, is what is the velocity and position at t equals 5 seconds? Okay? Pay attention. This is a very, very good problem. So let's start with the first part. He said the time to reach the maximum height. Again, we're going to be using, because the moment you leave the object off your hand, regardless whether it's going up or down, it is in free fall. You see what I'm saying? So the suitable equation to use here is basically the free fall kinematics. So what's given to us? Well, what's given to us, let me write down what's given to us. So we know that the initial velocity is 20 meters per second, and it is positive because it's going up. See that? It's going up. So it is, we put a plus sign there. the height, the initial height of the object is 50 meters, but since it is below, remember we have that x and y here, you get that x and y here, we call it the datum, so that's below that, so that will be negative. So you have negative 50 meters, okay? I'm trying to erase that thing, there we go. Okay, what else do we have? That's it, okay. So how do we do it? For the first part, I can use the first kinematic equation, V equals V naught minus GT. Now here is a question for you. What's the velocity, oops, I'm sorry. What's the velocity of the object at the summit right here? Well, it stopped, right? It stopped and then it returned back. So the velocity here would be 0, right? So here we have 0 equals V naught is 20 minus 9.8 times the time. Well, of course, we're solving for time. So in this case, if I do the algebra, and that's going to be 20 over 9.8. Is that right? When I calculate that, I will get 2.04 second. So it will take the object 2.04 second to reach the summit. So far, so good. Part B, he says, what is the maximum height? So what is that maximum height? Whether you measure it from the floor or from the level of the thrower. Again, one way to do that is to use the third kinematic, what it is, right? I would go with this one here. You can also use the second one. You shouldn't have any issue with it. But since I know the time, so I'm just going to use this one. You see what I'm saying? Let me use both of them. How about that? To show you that you will get the same answer. Let's start with, let me call that equation 2. This is equation 3, and of course this is equation 1. So let's start with equation 3. So here I have y equals v naught t minus 1/2 gt squared. So the maximum height, we'll call it max here, so that will be 20 times the time is 2.04, correct? The time that we found in part A here, minus 1/2 times 9.8 for the value of g times t squared 2.04 quarter t squared. And then I use my calculator. Go ahead and calculate that with me, guys. And we will get 20 times 2.04, answer 40.8 here, minus, and then the second part, and that will be 2.04 squared times 4.9. If I did it correctly, that will be equal to 20.4, okay? And then 40.8 minus 20.4, whoops, 20.4, and the answer, the final answer, is 20.4 meters. So there we go. That's the maximum height. Okay? Another way of doing it is to use the equation, the second equation. Let me show you. The second equation says v squared equals v naught squared minus 2gy. Of course, I'm solving for y. Let me do the algebra first. So y in this case is going to be v squared minus v naught squared over 2g with a minus. Yes, with a minus right there. So now I'm going to calculate that, and that's v squared is 0, right? At the summit it's 0, minus 20 squared over negative 2 times 9.8. As you can see, the minuses cancel out. So I'm going to get 400 divided by, what is it, 19.6. So I have 400 divided by 19.6. Answer is, again, same answer, 20.4. You see how you can use either equations, you'll get the same answer. Okay. The third part of the problem, he says the time to return to the level of the thrower. Okay, now there are like a couple of ways to do it. I can use the first kinematic equation, or I can use the third. It doesn't matter because he's asking for the time. Both of those equations contains time. Let's use the first equation. The first equation, yeah. So here I have v equals v naught minus gt. The time it takes to reach the level of the thrower. Now the question is, what is the speed? Let me go back to the diagram. What is the speed of the object here? You agree with me it is basically minus v naught, which is basically, there is a symmetry here, there's a parabola, so you throw the object with a speed of 20, by the time it reaches the level of the thrower, it should be negative 20. You see what I'm saying? So I already know what it is. Now I want to know the total time reached here. One way to do it also, you can just say double the time, because I calculate the time it goes from here to the summit, which is 2.04 right there. Well, by symmetry, it's basically going to be double the time, and it makes sense. So basically I can predict the answer, and it's going to be basically just double this number, 4.08, and you're done with the problem. But let's prove it. Okay, let's prove that. So here I have the velocity at the level of the thrower is basically negative 20 equals positive 20 minus 9.8 times the t, the time, and then we do the calculation. So that's you take that positive 20, move it to the other side, it becomes negative 40 equals minus 9.8 t. The minuses cancel out, as you can see, so the time is going to be 40 over 9.8. Answer 40 divided by 9.8 equals 4.08 as we predicted. 4.08 seconds. Got it? Another way to do it is to use the third equation. Let's see. So the third equation says y equals v naught t minus 1/2 gt squared. You see what I'm saying? So by the time it reaches the level of the thrower, by the time it reaches the level of the thrower, the gain in height is gone. So there is really no height gained here. You see what I'm saying? So here, remember this y, I'm measuring it from the level of the thrower. So that's going to be 0, and that's going to be 20 times t minus 1/2 gt squared. Okay? As you can see, this is a parabolic equation, but I can reduce it. Look at the t here and the t squared here. I can take out this t as a common factor and then divide it by 0, so I can eliminate it. So if I do the algebra, so that's going to be 0 equals 20 minus 1/2 gt, and then all I need to do is to solve for time. So that will be equal to minus 20 over negative 1/2 g. The minuses cancel out, so I'm going to get 20 divided by 1/2 g is 4.9, by the way. And when you calculate that, the time is going to be 4.08 seconds. Same answer. Either or method you can use to get your answer. Okay, now we come to part D. Let's read it again. It says the velocity at the level of the thrower. Well, we already know what it is, right? Let's suppose that we don't know. I mean, we know what it is. It's basically negative 20. But let's suppose we don't know that. So one way to do it, you use the equation, the first equation, the first kinematic. So v equals v naught minus gt. I want to find this v right here. I'm assuming I don't know what it is. So I'm just going to go 20 minus 9.8. I already calculated the time it takes it to reach the level of the thrower, which is 4.08 right there. And when you do that, you will get 20 minus 9.8 times 4.08, answer negative 40 roughly, and that will be negative 20 meter per second. Actually, as you can see, the mathematics takes care of it and it gives you that minus sign automatically, telling you it's pointing downward. Even if you don't know that, the math will actually tells you that. And the last part of the problem, he says, back to the problem, he said, what is the velocity? Here it is right here. He said, what is the velocity and position at the 5th second? Okay, at the 5th second. Again, you pick whichever equation you use. Again, he's asking for velocity at the 5th second. So we already know t is equal to 5 seconds. And what is the velocity? Well, I have those three equations. You pick either the first one or the last one, the third one, because they both contain time. I'll pick the first one because it's just simpler. V equals V naught minus GT. So the velocity on the 5th second, so this V naught is equal to 20 minus 9.8 times 5. So that will be 20 minus 9.8 times 5 equal to 49 here. And when I do that, the 20 minus 49 is negative 29 meter per second. What does that mean? It means on the 5th second, which is, let me go back to the diagram. The 5th second, I don't know exactly where, but it's probably, let's assume it is somewhere right here somewhere, maybe. So it is right here somewhere. And on the 5th second, it's pointing downward like that. And that's the velocity we're looking for. You see what I'm saying? And so the velocity there is equal to 29, when I get there we go, it's equal to 29, negative 29 meter per second going downward. The minus sign means downward, correct? Okay, now he's asking what is the position of it. In other words, what is the height of that, of the pencil or particle, whatever, at that position. I can use the third equation, y equals v naught t minus 1/2 gt squared, and that will give me 20 times 5 minus half 9.8 times t squared is the 5th second squared. I do the calculations here. 20 times 5 is 100 minus 4.9 times 25, answer 122.5. And when I subtract them from each other, I'm going to get a distance of negative 22.5 meters. There we go. That's the position of the particle. You got it? Okay, good. Let me just look at my notes very quickly. Now I want to go to the homework. Maybe I'll do a couple of problems, or let's see. Let me do number 38. 38 and 54. How about that? Looking maybe for a harder one. Yeah, number 38. Let's do 38 for now. See what happens. So let me go to the problems. I'm going to go to the third chapter and work backwards to number 38. Oh, I know I have the hard copy. I can just look up the page number. Hold on. Number 38, page 61. Let's just do it. Oh, I can just scroll to 61. Right there. What is it? Right here. Shall I magnify it? Right here. Do you see it? Okay, it says a car sitting at a red light begins to accelerate at 2 meters per second squared. Okay, so we know the initial velocity is 0. That's quick ideas. Let me just put it on the side like that. So we have a car, initial velocity is 0, and acceleration is 2 meters per second squared. Okay, 2 meters per second squared. I like to write down everything as I read the problem. It helped me solve it. Okay, so a car sitting at the red light begins to accelerate at 2 meters per second squared when the light turns green to me. Okay, it continues with this acceleration until it reaches a speed of 20 meters per second. Okay, so the new velocity, or the final velocity, is 20 meters per second. Okay, it then traveled at this speed for another few minutes. Question: how far does the car travel in the first 30 seconds after the light changes to green? Okay, so let's look at it. So what you have in here is the car, here is the road, here is the car. The car is sitting at the red light, so this is the initial velocity, 0 at t equals 0. And then now the car is moving with acceleration of 2 meters per second squared, and it reaches a speed eventually. Here is, let's say it reaches the speed right here at the speed of 20 meters per second, and it continues on for the next 30 minutes, for the next 30 seconds, is that right? He says it continues at this acceleration until it reaches a speed of 20. I'm asking the question here, really, how long does it take the car to reach that speed? That will be one legitimate question. And then it travels for another few minutes. How far does the car travel in the first 30 seconds after the light changes to green? Okay, so let me ask the question first. How long it took the car to reach v equals 20 meters per second from v naught equals 0? I want to know that, because he wants to know the total distance. Well, I need to know the time, because I want to know the distance traveled while the car is accelerating. This is this period right here. While the car is accelerating right here, this is one distance. And then the other distance, x2, while the car is moving at constant speed here. You see what I'm saying? This is the car is moving at constant speed. Oops. So I want to find x1. So if I know that how long it took the car with kinematics, I can find x1. All right. So I go back to kinematics. This is not free fall, so I'm just going to use the usual kinematics. I'm going to use equation 1, v equals v naught plus at. I am given the velocity of the car, 20 equals 0, plus a is 2 times t. So it is 20 over 2. So basically, it took the car 10 seconds of acceleration until it reaches the speed of 20. Got it? So now I can find the distance traveled during this acceleration. Do you see what I'm saying? The distance traveled. Remember that distance with acceleration. So I can use equation number 3. X equals v naught t plus 1/2 at squared. And that's what I'm calling x1 right there, guys. Right? This is x1 right here while accelerating. So that's going to be x1 equal to v naught is 0 times t plus 1/2 times a is equal to 2 times t squared is 10 squared So that will give me 100. Is that okay? So this is the distance while accelerating. Okay. Now I'm interested in x2. Now what's going on in x2? Well, the car at this stage right here, it reaches 20 meters per second and continues on at constant speed, which means what? No acceleration. You see what I'm saying? No acceleration, which means what? I'm just going to use the usual equation that we have studied before, and that is x equals vt. Remember that? The one that doesn't have acceleration. So x2 is just going to be vt. Well, how long is the time? Well, see, it took the car 10 seconds to accelerate, and then we have the total distance, the total time here, x1 and x2 is 30. So the time here, the new time, if we call it t2 if you want, so this t2 is equal to 20 seconds, the remaining, right? Remember, this one is t1, 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 t1. Okay, so now I go back, so I say x2 is equal to, the velocity is 20 times 20 seconds, and that will give me 400 meters. Oops. And therefore, the total time, the total displacement, or total distance, is x1 plus x2. And that will be 100 plus 400, and that's equal to 500 meters. That's the total distance traveled by the car. You got that? Okay, good. Let me do number 54. This problem requires a little bit of a higher algebra. Let's look at the problem first. Number 54. Right there. Try to move it to the side. Let's read it together. It says a rock. Oh, look at that, level 1. I don't think it's level 1. I would put it at least level 2. It says a rock is thrown vertically upward with a speed of 12 meters per second from the roof of a building that is 60 meters above the ground. Okay? Kind of similar to the problem that we have just done. A, in how many seconds, he's asking for time, after being thrown does the rock strike the ground? He's basically asking, what is the total time of flight of the rock? You see what I'm saying? And number 2, what's the speed of the rock just before it strikes the ground? Okay, assume free fall. All right, let's see. Let's draw a free body diagram and write down what's given to us. So it looks something like that. Here is the building right here. Here's the ground. Here's the rock thrown directly upward like that, and then it falls to the ground like that. And then there is the rock right before it hit the ground, if you know what I mean. And that is the velocity, v naught, which equals to 12 meters per second. Okay? So he wants to know the total time of flight. And he's asking for the velocity just before it hit the ground. Okay? All right, again, this is free fall kinematics. Let's start with the first part. First problem, the first equation that comes to my mind is the third one. Y equals v naught t minus 1/2 gt squared. You see what I'm saying? The height of the building, he said, is negative 60. Negative, right? It's below the rock. And so we know what y is. and we know V naught is given to us right here. So basically I'm just going to plug in everything in my equation right there, and then I'm going to end up with a quadratic equation. Okay, look at that. So that's going to be negative 60 equals 12t minus 1/2 times 9.8 is 4.9. I hope you memorized that by now. Times t squared, and there we go. As you can see, we have a quadratic equation. All I need to do is to solve for the quadratic equation. So let me put everything in one side. So move the right side to the left side. You see what I'm saying? You can do it the other way around, doesn't matter. So I'm going to end up with the following: 4.9 t squared minus 12t minus 60 equals 0. This is my quadratic equation. So I'm going to use the quadratic formula, which is t equals minus b plus or minus square root of b squared minus 4ac divided by 2a, just like that, right? And I'm just going to plug it in. I assume you know how to do the quadratic formula. The only difference between this quadratic formula and the quadratic formula that your math instructor had taught you is that because this is a second degree equation, you always get 2 roots, correct? And of course that's correct, but because this is physics and this is time, and there is no such thing as negative root for time. There is no such thing as negative time. You see what I'm saying? So when you work it out, you only pick that positive value. You're not going to get 2 negative. If there is 2 negative, there's something wrong with the way the problem is worded. You know what I mean? So you will always get 1 negative, 1 positive. Now, if there are 2 positive, then you have 2 answers. But I'm predicting for this problem, I haven't done it yet, I'm predicting for this problem, I'm probably going to get 1 negative and 1 positive. And then, of course, you're going to disregard the negative because there's no such thing as negative answers, negative time. So you're just going to take the positive value, and that's it. Basically, that's the time of flight. You see what I'm saying? Okay, let's start with it. So we have, let's plug it in. So we get negative 12 plus or minus square root of b squared, which is 12 squared, which is 144, minus 4ac. 4 times a is 4.9. C is negative 60, so I'm going to put the 60 here and put that, see that? I want to put a minus here. Well, anyway, take that minus, and then I'm going to go and put it right there, and this becomes a plus. You agree with me on that? Just like that. Divided by 2 times a is equal to 4.9. And there we go. We have that, and let's use the calculator to calculate all of this. So I'm going to get 12 plus or minus square root of 144 plus, using my calculator, I hope you're working with me. So we have here 4 times 4.9 times 60, answer 1176, divided by 9.8. And then we have, as you can see, we have 2 answers here. Let me just simplify this root. So I have here 144 plus 1176. Answer, take the square root of that thing. Answer 36.3 divided by 9.8. So here we have 2 answers. The first one is time equals to, take the positive one. So that's going to be 12 plus 36.3 divided by 9.8, answer 4.93. Second, this is a legitimate answer. It's a positive time. Let's take the other one, and that will be, as you can see, it's going to be negative, right? 12 minus 36.3 divided by 9.8, and that's going to be negative 2.48 second, but of course that's wrong. Your math teacher would tell you these are the 2 legitimate answers, but in real life there is no such thing as negative time, so we basically just ignore that thing right here. Just ignore it. You see what I'm saying? And that's our answer right here. So the time of flight, the answer is equal to 4.93. You got it? Okay. Part B, let me write it down. So we have time is 4.93 seconds. Part B, he says, back to the problem. He said, what is the speed of the rock just before it hits the ground? Okay. I can use the second kinematic, free fall kinematic, which is this one. He's looking for, excuse me, he's looking for V, and I already know V naught, and I know what Y is. All I need is just to plug him in and then work it out, and that should do it. Of course, be careful. When you take the square root of V here, you're always going to pick what? The negative root, because it is pointing downward. According to the diagram that we have drawn here, it's going to be, here is the diagram right here, right there. And so the velocity here is going to be pointing downward like that, and that's negative. You see what I'm saying? Because it is a velocity in the downward direction. So we're going to pick the negative answer for that. So V squared equals V naught. V naught is what? I forgot it already. 12, sorry. So we have 12 squared minus 2 times 9.8, and times the height is what? Negative 60. Don't forget that negative. So that's going to be 144 plus, right? You have a negative and negative here. So that will be 2 times 9.8 times 60. Answer 1176. We add them up together. 1320. And therefore the velocity is the square root of that. And I'm going to get an answer of course, that's the square root of a number. And since the velocity here is downward, I'm going to pick that negative. I'm going to impose that negative sign. And so that answer is going to be negative 36.3 meters per second, pointing downward. Okay. And I think that should be good enough. Let me just go back to mastering. Here's the home page right here, all assignments. And this is the homework number 2 here. And the problem that you need to do are these. Problem number 2, 3, 33, 34, 38. I've done 38 for you, didn't I? I think I did. Yes. And 54. Those are the 2 that I've done for you. And then you have the rest of them to do by yourself. Of course, if you have any question on those, simply just post it under Ask the Professor, and then we will take it from there. Okay? And that's about it for this today's lecture. Have a wonderful day. Bye-bye.